In today's class, we're gonna cover brazing, soldering, and adhesive bonding. So 3 joining processes. In brazing and soldering, both use filler metals to join two metal parts to provide a permanent joint, but it is difficult to disassemble the parts after they are brazed or soldered. And brazing and soldering lie between fusion welding and solid state welding. A filler metal is added in brazing and soldering. However, no melting of the base metal occurs, which is similar to solid state welding. So brazing and soldering, they are differentiated by the melting temperature of filler metals. Brazing takes place above 450 degrees C and produces stronger joints than soldering, and therefore soldering involves lower temperatures. So after we learn about brazing and soldering, we will learn about adhesive bonding, and a variety of adhesives are available, and then we're gonna learn about mechanical joining, such as use of bolts, nuts, and rivets. So in most joining processes we have described, the surfaces of the components are heated by various techniques to cause fusion and bonding at the joint. But think about if our parts are fragile and if two metals have two different characteristics, dimensions. What if they cannot withstand high temperatures like electronic components? Therefore, the brazing and the soldering technique that we're gonna learn about, they require lower temperatures than those used for fusion welding. Filler metals are placed in and supplied to the joint. They are melted by an external source of heat, and when they solidify, a strong joint is formed. And these two processes, brazing and soldering, they are differentiated, as we talked about, by the temperature, and lower temperatures are for soldering and higher for brazing, and you can see the temperature ranges given in the slide. And we have also talked about soldered joint is the strength of the soldered joint is much lower than in brazing. Here in these images we are seeing examples of brazed and soldered joints. The first one is resistance brazed light bulb filament, right? And in the second, brazed rocket tubing assembly, and in the image C we are seeing soldered circuit board. Let's first learn about brazing. Brazing is a joining process in which a filler metal is placed along the periphery or between interfaces of the faying surfaces to be joined. Then we raise the temperature to melt the filler metal, but not the components, which was the case in fusion welding. So upon solidification of the filler metal, the strong joint is developed. And in brazing we talked about typically metals melt above 450 degrees C. So let's look at the image here to understand. Here you see in the brazing operation, braze metal in the form of a wire is first placed along the periphery of the components to be joined. You can see here, like shown with blue. And then heat is applied and it melts the braze metal. And then braze metal fills the closely fitting space at the interfaces through capillary action. Several filler metals are available. Of course, they have a range of brazing temperatures. And in brazing, we can join dissimilar metals, and the filler metals can be in the form of a wire rod or fillings. So we need to avoid formation of galvanic corrosion, because if we select a wrong filler material, that can create, since the electronegativities are different, that can create a galvanic cell, and this is a form of a corrosion process that can take place. Or with time, different metals can diffuse into each other, and that can create formation of intermetallic compounds which might be brittle, and this will cause the joint to be brittle. Unlike fusion welding, in this case filler metal has a different composition than the metals to be joined. There are advantages of brazing compared to welding techniques we have learned. So again, as I said, any metals can be joined, and this technique can be performed quickly, and thin walled parts that cannot be welded, brazing can be applied to join those thin walled parts. And of course, when the heat is required is less compared to what is required in fusion welding, problems with the heat is reduced, such as heat can affect the base metal, so the structure of the base metal can change, but this type of problem is reduced in this type of joining process. There are of course disadvantages and limitations of brazing. Here the joint strength is less than that of a welded joint, and high service temperatures may weaken the brazed joint. And there are aesthetic disadvantages, like the color of the metal in the brazed joint might not match the color of the base metal. Flux has the same purpose, just like it had in welding. They dissolve and combine with oxides and impurities, unwanted products, and pretty much it prevents these oxides and removes oxides films. They are generally made of borax, boric acid, borates, fluorides, and chlorides. And wetting agents may be added to flux. This can improve wetting characteristics of the molten metal and its capillary action. So in this table we are seeing common filler metals used in brazing along with the base metals on which they are typically used. So to qualify as a brazing metal, some characteristics are needed. So the melting temperature must be compatible with the base metal. Surface tension in liquid phase must be low because this is important for good wettability. And fluidity of the molten metal must be high because it needs to penetrate into the interface. Also, like chemical and physical interactions with base metal, galvanic corrosions, must be avoided. Soldering is similar to brazing and can be defined as a joining process in which a filler metal called solder with a melting point not exceeding 450 degrees C is melted and again distributed by capillary action between the faying surfaces of the metal parts being joined. As in brazing, here also no melting of the base metal occurs, but the filler metal wets and combines with the base metal to form a strong bond. As an industrial process, soldering is most closely associated with electronics assembly. It is also used for mechanical joints, but not for joints subjected to elevated temperatures or stresses. Advantages of this technique is low energy input compared to brazing and fusion welding. A variety of heating methods are available: torches, ovens, good electrical and thermal conductivity in the joint, and easy to repair or rework. Disadvantages, on the other hand, is low joint strength and possible weakening or melting of the joint in elevated temperature service. Two important characteristics of solders: their low surface tension and high wetting capability. So solders melt at the eutectic point of the solder alloy. So traditionally it has been tin lead alloys since both metals have low melting point. For special applications or higher joint strength, especially at elevated temperatures, other solder compositions are available like tin, zinc, lead silver, cadmium silver, zinc aluminum alloys. Tin promotes the wetting action required for successful joining. In soldering copper, which is common in electronic connections, intermetallic compounds of copper and tin are formed that strengthen the bond. And there is also lead, and lead is toxic. So lead-free solders have been developed. Metals such as silver, zinc are being alloyed with tin to formulate these new solders. And here you see a selection of common solders and their applications. And again, flux is used for the same purpose here as they do in welding and brazing. So solderability is something related to similar to weldability. So here copper, silver, gold are easy to solder. Iron, nickel are more difficult. Aluminum, stainless steel difficult because of the formation of thin, strong oxide films. Another type of joining process is adhesive bonding. It uses adhesives made of rubber or a polymer as a filler material. So the filler material that binds the parts together is the adhesive. Joint strength in adhesive bonding is determined by the strength of the adhesive itself and the strength of the attachment between the adhesive and the parts that are being joined. Adhesives are available in liquid, paste, solution, emulsion, powder, tape, and film. So to meet the requirements for a particular application, an adhesive may require one or more of the following properties. So it requires strength, shear strength and peel strength, toughness, resistance to various fluids and chemicals, resistance to environmental degradation, including heat and moisture, and capability to wet the surfaces to be bonded. So several different types of adhesives are available. They are classified into 3 categories: natural, inorganic, and synthetic. Natural adhesives are derived from natural sources like plants and animals, such as starch, soy flour, and inorganic ones. So these natural ones, usually this type of adhesive is generally limited to low stress applications. So inorganic ones are usually sodium silicate, and this type of adhesive is relatively low in cost, but they are also low in strength. The most important category of adhesives is synthetic adhesives. These are thermoplastic and thermosetting polymers. Many adhesives may be combined to optimize properties. Epoxies and phenolics, these are the least expensive ones, and high temperature applications are the most expensive. For most adhesives, optimum temperature ranges between 20 to 200 degrees C. And these adhesives can also be combined with mechanical joining to improve strength. So if you look at the advantages here for adhesive bonding, so bond strength is sufficient for such structural applications, but it is also used for non-structural purposes such as sealing, insulation, preventing corrosion, reduction of vibration and noise. Adhesive bonding effectively distributes the load at the interface. This eliminates localized stresses that can result from joining components with mechanical fasteners. The external appearance is unaffected, and thin and fragile parts can be bonded without significant increase in their weight. The limitations are limited to a limited range of service temperatures and the need for great care in service preparation. And degradation of the bonding due to environmental conditions, temperature, oxidation, corrosion, radiation, etc. So this table is for your future reference. Here we are given different type of adhesives like epoxy, polyurethane, and their characteristics, like what are their impact resistance, is it good, is it bad, shear strength, and temperature range, service temperature range, and toxicity, flammability, some properties for different types of adhesives, common adhesives are given. Again, in this table, different type of adhesives and some comments on them and their applications, like what type of adhesive it is it a thermoplastic, thermoset, and because it is important whether it's a thermoplastic or thermoset in the preparation, and what type of applications they are used for. This is the continuation of that table, just general characteristics of the adhesives and applications for your future reference. So mechanical assembly consists of various methods to mechanically attach two or more parts together, and in most cases the methods involve the use of discrete hardware components called fasteners that are added to the parts during the assembly operation. Many consumer products are produced using mechanical assembly, like automobiles, large and small appliances, cell phones, furniture. So there are reasons why mechanical assembly is preferred over other joining processes, because there is the ease of disassembly, right? This is important because sometimes the disassembly required for to have so that the maintenance and repair can be performed or parts can be replaced. We can make adjustment, but the joining processes like welding, they don't allow for disassembly. So when we say fasteners, these are pins, rivets, such as threaded fasteners like bolts, nuts, screws, etc. So mechanical assembly, mechanical fastening typically requires that the components have holes through which the fasteners are inserted. And therefore first we need to prepare the holes, and we learn techniques for that, like drilling, right? The joints will be subjected to shear and tensile stresses, so when we are designing we should be careful such that these joints can resist such forces. And because we need to make a hole, and we also know that hole tends to cause stress concentrations around them, and this will reduce fatigue life. So there are threaded fasteners. These are they have external and internal threads for assembly. In many cases they allow for disassembly. Threaded fasteners are the most important category of mechanical assembly. The most common threaded fastener types are like screws, bolts, nuts. There are rivets and pins like you are seeing here, and other fastening techniques like metal stitching, stapling, similar to stapling of papers like you see here. There is seaming, basically a simple principle of folding two thin film materials together, like joining two pieces of paper by folding them together at their top left corners, like this one you are seeing. And there are snap end fasteners. These are commonly used in automobile bodies, household appliances, economical, and permit easy and rapid assembly. So when we are designing with mechanical joints, we need to consider important points like the type of loading, or consider the size and spacing of holes, capability of fasteners and component materials. I think this is wrong. This should be compatibility, right? Because if the materials are not compatible, they might lead to corrosion. So are the materials compatible with each other, or they are in a way that they can lead to a galvanic corrosion? An example is aluminum or zinc fasteners on copper. Aluminum zinc fasteners on copper can cause corrosion, galvanic corrosion. It is often beneficial to use fewer but larger fasteners than using a large number of small ones, because as we talked, the formation of holes in the part, they are acting as stress concentrators, weakening the part basically. Part assembly should be accomplished with a minimum number of fasteners. So in summary, we have learned brazing, soldering, and we learned the difference between them, their capabilities. Then we talked about adhesive bonding, and then we talked about mechanical fastening, like screws, nuts, and rivets and fasteners. And with this chapter we are concluding the joining processes.